Okay, yeah. Again, it's bad grammar. We will look, it's supposed to be, we will look at functions, I think, curvature in terms of concavity. So it just depends on how the function is curved, right?
Yeah.
So concavity comes in two flavors, concave up and concave down. Okay, if it's not concave up or concave down, it's a straight line. It's just a straight line. So it doesn't matter what the function is, it's going to have either concave up, concave down, or no concavity, zero concavity. Okay, so these are two examples of concave up, concave down. Okay, these are easy to tell. That's concave up, kind of cup, right? Cup holds water, spills water, that kind of thing. But if you look at the bottom of the page, sometimes it's kind of difficult to tell because I color-coded it just to show where it's concave up and concave down because I've had students in the past say they can't really tell because if you look at the pink, that's technically concave up. Why are they different colors? It should have been, I color-coded it wrong. This should be, everywhere it's concave up should be the same color. And this should be, no, that's right. This should be the same color. Okay. Okay. So you look at the pink, all right, and you're like, that doesn't really hold water, but it's concave up. Okay. Even though it's cupped upwards or cupped downwards, the graph. Okay. So sometimes it's kind of hard to tell whether it's concave up or concave down. So sometimes a picture can be deceiving. Okay. Hey, what's up? Forks? No, I don't have any utensils, sorry. So pictures can be deceiving a little bit. So again, we're not going to look at a lot of pictures, but the idea of what is concave up and what is concave down, these are, I gave you, there's some pictures down here too of what it looks like, okay? So, but yeah, that is what concave up is down, holds water, spills water, right? Frown, sad face, that kind of thing, okay? Okay, so what is, so they're the same thing, right? Yeah. Happy face, sad face. Happy face, sad face.
I think I would prefer.
Okay. Second derivative test. So second derivative test tells us about concavity. Just like the first derivative test told us about increasing or decreasing, if the function is increasing or decreasing. Second derivative test doesn't tell us anything about increasing or decreasing, but it does tell us about concavity. Concave up or concave down. So if the first derivative is positive, greater than zero, or sorry, the second derivative is positive, greater than zero, it's concave up. Okay, it's concave up. If it's negative, the second derivative is negative, it's concave down. If the second derivative is equal, it's a straight line and therefore it has no concavity. Okay, so at that dot, see these dots here? That's where the concavity would be zero. Those dots have special names. They're called inflection points. So inflection points is where a function changes concavity. Does it change from concave up to concave down? If it does, it's an inflection point. Does it change from concave up or concave down to concave up? That's an inflection point. If it doesn't change, there is no inflection point. It's kind of like critical values. Right? For first derivative, critical values were where the function changed from increasing to decreasing, right? Or vice versa. So essentially they're the critical values, but for second derivative. So it's where second derivative equals zero. Okay? Yeah. A lot of what we do today, it's gonna look like what we did, not last lesson, but the lesson before that with first derivative tests, because it's essentially the same steps. We just don't use the first derivative. We use the second derivative. Okay. All right. So that's what second derivative test. It changes. It checks for concavity, concave up or concave down. Okay. So that's what the first page is. Okay. And then the rest of them is just practice problems. Okay. Examples. So let's look at example number 1. Okay. They want to know where is it concave up, where is it concave down, and where are the inflection points? Remember, inflection points are changes in concavity. Where does it change in concavity? Okay? So when you see anything about concavity, always, 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 it's second derivative test. Second derivative test is always for concavity. So if you see the word concave at all, second derivative. You're going to need to do the second derivative test. If it talks about increasing, decreasing, maximum, relative minimum, that's the first derivative test. Okay, so just keep them, you got to keep them separate. Okay, and then even if it talks about inflection points only happen with concavity, so that's second derivative. Okay, so the first thing is we need the second derivative. So we're going to find the first derivative. First derivative, 3x squared minus 6x, right? Go to the second derivative. Second derivative is 6x minus 6. So the first thing we got to figure out is where is the second derivative equal to 0? Where is the second derivative equal to 0? Those are going to be inflection points. Okay? So we set the second derivative, which is 6x minus 6 equals 0. You can factor out a 6, or you can just add 6 to both sides because it's linear. Divide by 6, and you get one inflection point at 1. So remember, that's going to be an inflection point. 1 comma something, right? 1 comma something. Okay. If we want to know where, we would plug in 1 to the original, and we could figure out where exactly they want, if they want a point. Okay. Second thing is, where is it concave up and where is it concave down? Well, now we go to our number line. Any inflection points, we're going to put on our number line. Well, we only got 1. We only got 1. So we need to check above or greater than 1 and less than 1 for inflection points, or for concave up or concave down. So we're going to do the same thing we did with first derivative test. Pick a number less, pick a number greater. We don't care about the number, right? We care about positive or negative. We care about the sign. Okay? So 0, -1, -2, whatever number you want to use there, we're going to plug into the second derivative. I'm going to choose 0. Second derivative, because it's the second derivative test. Okay? So the second derivative was 6x minus 6. That's 0 minus 6, that's -6. So that means it's going to be negative. Negative means concave down, spilling water. It's going to spill water before 1. Again, don't assume that it's going to be positive after 1, because most of the time, yes, it will change, but there will be a few times when it stays the same. So we actually have to check the second derivative. So I'm going to plug in 2. You can plug in 3, 4, 10, whatever number you want, but keep the numbers small while you can. +6. Okay? So that means after 1, it was concave up, holding water. Okay? So it says inflection points. How do I figure out the y? Like I said, plug it back in. Plug it back in and you can figure out where the inflection points are. I'm okay with you just leaving it as x equals 1. I'm okay with that. Okay? But if they actually want a point, then you would plug in back to the original. It's not hard, but it's just a step you would have to do. Okay? So here we go. Concave up. Right? So concave up was started at 1 and went to positive infinity. Concave down started at negative infinity and stopped at 1. And then inflection point at x equals 1. Done.
Okay.
The mechanics of this you've done before on first derivative test. Okay? The biggest issue I see for students when they prepare for a test or a quiz is they get them mixed up. They're like, okay, I'm like, for concavity, what do we use? First derivative, second derivative. That's where they know the mechanics. They can do this. But where they get stuck is when do I use first derivative test? When do I use second derivative test? Okay, so if that's something for if you don't want to memorize that, that's a great thing to put on the card. Okay, just quick little note. First derivative test is for increasing, decreasing, relative maximum, relative minimum. Second derivative test is for concavity and inflection points. Okay? All right, let's do number 2. Okay. Again, concave up, concave down, inflection points. That means second derivative. Okay? So we're going to have to use we're going to have to find the first derivative. We're going to have to use quotient rule because it's a quotient problem. So we have x squared plus 3 squared on the bottom. The top is low times the derivative of the high. The derivative of 4 is just 0. So you're just going to distribute a 0 there. And then the high times the derivative of the low, which is just 2x. Okay. Simplify. Well, again, when you distribute 0, you're just going to get 0. So all of this stuff will be gone. So you're going to get negative 8x over x squared plus 3 quantity squared. Okay. Now we got to do second derivative. That was the first derivative. Now we got to find second derivative. So we're going to use. Did you do something wrong?
No.
No? Good so far? Okay. Yeah, let me know if I do something wrong. Chain rule, or the quotient rule again. So the bottom is squared. So the first derivative is squared. So what power is it going to be now? 4, yeah. If it's already to the second power, and then you square that again, 4. Okay. Low times the derivative of the high, which is negative 8, minus.
Wait, no, wouldn't it just be the squared?
Yeah, that was squared.
Oh, squared. Why did I put? Yeah. Thank you.
I think you got too much on the 4.
Okay. So now the derivative of the low, which is, chain rule. We're going to have to use the chain rule for the derivative of the low. So it's 2x squared plus 3 to the first power. And then times the derivative of the inside, which is 2x. Times the derivative of the high, or sorry, times just the high, not the derivative of the high. So that's 8x. Okay, that's the derivative. We just have to kind of clean it up a little bit. So combine like terms, distribute where we can, do all that stuff. Okay. So the first brackets, we can't distribute the negative 8 since it's squared. So we have negative 8x squared plus 3 minus. This is where we can do something. I can distribute the 2 because it doesn't have a power besides 1. The power is just 1. And then I can multiply this guy and this guy times. So let's do this first. Before I distribute, let's multiply the monomials first and then distribute. So that's going to be negative 32. So we'll have negative 32x squared, and then x squared plus 3. So we're going to distribute that. Bottom stays the same.
This looks evil.
Okay. All right. Squared, yeah, just saw that. Yep, I did. Negative 8x squared plus 3 squared minus, and then I would have, actually it's going to be plus, right? But for right now, let me just keep it. Negative 32x to the third power, right? And then what is 3 times negative 32? Negative 96 x squared. Distribute the negative, so that would be positive, positive, positive. Yeah, x 30, negative 30, or 32, yeah. Yeah, I don't know why we're at third. Okay. That's as far as I'm going to simplify it for right now. Okay.
Do you want to use simplifying to you?
Okay, so we're right here so far. So this is the second derivative, sorry. So we've dealt with first derivatives that have top and bottom, right? So when the top is 0, that means the whole thing is 0, right? When the bottom is 0, that means it's undefined, right? So I'm definitely going to set the top equal to 0. Why would I not set the bottom equal to 0?
Because you're going to get undefined.
Because there's no, well,
Also because it's an x.
there is no 0. Yeah, there's no number I can plug into the bottom that would make 0. Because I automatically square it, then add 3, then take it to the fourth power. There's no number that exists. The only number that exists is imaginary, and we don't deal with those. Okay? So you could actually solve that, and you'd get an answer, but it would be like negative, it would be like plus and minus square root of 3i. Or I times the square root of 3, something like that. We don't want those. So at the bottom, I'm not going to consider. I'm just going to focus on the top now. Okay? I'm going to focus on the top. So I'm going to set the top equal to 0. So this is plus 32x4 plus 96x squared equals 0.
How are you going to get these to cancel out?
Okay.
Squared. X squared plus.
Oh, squared, yep. Forgot about the squared again. So first thing I got to do is actually get rid of that squared so I can distribute the negative 8. Okay? So it's really x squared plus 3 times x squared plus 3. So x squared, so you have,
That makes it x.
so it's just,
4 plus 6x squared.
it's really this, right?
9.
Yeah, so if you can do it in your head, that's awesome. As much work as you can do in your head, that's great. If you can't, actually write it down and do FOIL. First, outer, inner, last.
I do box.
Okay, box is great too.
I just never got behind 4.
Okay, so we would have x to the fourth plus 3x squared plus 3x squared plus 6x squared
Plus 9.
plus 9, yeah.
It's minus, it's minus 8 for minus 48.
So the thing I don't want you to do is I've had students do this. They just, for this guy here, they just square it. So they get x to the fourth plus 9. That's not using, right? I know. Not you guys, but I'm just saying, people outside the classroom, right? No one in here, obviously. Okay. Distribute. Now we can distribute.
48 minus 79, so 2 plus, so 24x.
Okay. Combine like terms.
24x. 24x? Yeah. 24x to the fourth plus 48x squared minus 72 equals 0.
Oh, before I forget, so the 12th is the last day to sign up for the AP test. Okay? So It's about a week away.
we-
So if you're interested in it, talk to Miss Carbajal. She's the finance secretary in the front office. Okay. I'll post it on Google Classroom too. I just haven't had a chance to, but
I don't got paper, do we?
yeah.
Did we get anything?
No, but I thought we were supposed to get a paper.
Oh, we were supposed to, but we didn't.
I'll look. I haven't got any papers, but
Shoot.
okay.
Oh, we're getting $5.
I think before this, so I can probably get it. I got Carlos actually. Carlos to talk to.
It's not required, but if you want, the only way to get
It's pretty much required for me.
college credit is to take the test. Okay. So combine like terms, we get. Why do I get numbers that are not?
Why do I get numbers? Why do I get numbers?
Oh, wait. Here we go. No, sorry, I did it a different way last year, but it's okay. So combine those two. What do we get? 24.
Yeah.
X4. Then we combine these two guys. What do we get? 48x squared
Hey, wait a minute. Can we together?
minus 72.
Wait,
Yep.
we can't. Because of 0.
No, we can divide it by 12. GCF.
So that makes it 2 plus 4 minus 6.
So 24. We could actually go by 24.
Oh, wait, yeah, we can. X plus 2 minus 3.
There you go. So we get x to the fourth plus 2x squared minus 3.
This is peak. Oh, yeah. Now this is coming together.
I still felt like this was, I would say,
So the two numbers that multiply to be -3 and add to be 2.
3 and...
Positive 3.
Positive 3 and minus 1.
There we go. Since it was x to the fourth, it's going to be x squared and x squared. 24 is not going to have any bearing on the on anything. It just needs to be in front because it's a GCF. And then this guy here, you can actually solve it right now, or you can say you can do that guy's difference of squares. So let's say you forget that's difference of squares. You can still solve it and you'll get the same answer. So now what we're going to do is we're going to set this guy and this guy equal to 0. Zero product property says if I multiply two things and I get 0 as an answer, one of them had to be 0. Which one? I don't know, so I just assume both are 0. That's what zero product that's why I set each of them equal to 0.
One is 1.
So I can already tell the one to the left is going to give me a imaginary answer. Because if I subtract 3 from both sides and take the square root, that's going to be imaginary. So we're not worried about that.
But hey, we got a 1.
This guy over here, we add 1.
It's back.
You square root it. Remember, anytime you square root, you get two answers, right? You get positive 1 and negative 1. So we have two inflection points, one at positive 1, one at negative 1. Okay. Okay. So now we have to do our test.
Oh, we got.
Yeah. We haven't
So
even.
correct me if I'm wrong. We're not gonna plug in. We plug in
yeah, plus or
minus 2 to that.
To the second derivative. Here's the thing. I don't care what the number is. I want to know if it's going to be positive or negative. So try to do as much mental math as you can when we plug in -1, or we plug in numbers, right? Try to do as much mental math as you can so that you don't need, we don't care what the real number is. Okay. So the second derivative, we hadn't seen it in a while, is, what was it?
What?
minus 8. It's this monstrosity of a number right here.
It's a monstrosity.
Equation.
Say that again.
You don't think a
And the nice thing is we're always going to get a positive number on the bottom. So we don't have to consider the bottom because the bottom is always going to be positive. Doesn't matter what number. So we just have to do enough mental math to figure out what the heck's going on top.
The only possible thing that I think would give us
Okay.
is if we do like
So here we go. Let's try less than -1, -2. So we would have, again, I'm not worried about the bottom because I know I'm going to get a positive number on the bottom.
I'll get positive. Use the super cool short one.
7 squared.
so that's like
Super cool short one.
minus
Oh, wait,
8
I thought
times
you did
49.
8 times 2.
Oh, what's 8 times 49, guys?
16 times 32.
Okay.
So it's- oh, they're all going to be positive. No, they're not. They're all going to be negative.
No, they're all going to be positive, right? Because it's 4 power squared. See, it's all the powers are squared, right? Squared,
32
squared,
times
4. So it's all going to be positive. So, but there's just that -8 in front that we got to deal with, right? So we got to figure out, is this part bigger or is this part bigger? Which part is the biggest to do, right? Here's the thing. Here's the yeah. So we know that this part is going to be positive. We know that this part is going to be positive. We know that this part is going to be positive. The -8 though is going to throw the wrench in there. It's going to it'll make this part negative, right?
Yep.
So this part here, let's kind of do mental math. What are we going to get with this part here? What number would we get if we did this?
8 times 49?
Around 49 times 8?
Yeah, 40
Okay.
times 9, 8. That
49
is
times 8.
392?
This guy here, we're going to get a positive number, right? It's going to be 16 times 32. This one's going to be 96 times 4. Add those two together, would we get bigger than this guy?
Yeah.
Yeah.
The first one's bigger anyway.
Yeah, the first one was bigger, way bigger.
So we're going to get positive over a positive, which
Oh,
equals
so
a
it's
positive number. Okay? Zero's nice because 0 cancels everything out.
It's mine.
Minus.
I'm guessing.
No, it is because the minus 8 minus 9.
Oh yeah, because the
Oh,
other.
yeah, this one.
Yeah.
Because the other one's
8 minus
disappeared.
8 times 9. That's going to make it minus.
Mine. No, I just plugged it into the super cool short version.
Damien, stop trying to like trademark that.
Oh, yeah, you're using this one down here?
Yeah.
Yeah, x to the
Yeah.
4th, yeah. That's smart.
That was an option? That was an option?
Yeah.
What do you mean?
It's a reduced version of what we're using.
Took it out.
And then it becomes.
I said I was using the super cool short version.
Yeah.
He kept going like, you guys, we could just use the super
Why
cool.
were we now using the super cool short
Okay.
version, guys?
Stop trying to trademark it.
I trademarked it.
So this is 0.
Quote Damien.
That is 0. That guy's going to be negative, right? Because it'll be 3 squared, which is 9, times -8, which is -72. So we would get a negative over a positive, which makes a negative.
And it's just positive again. That's just.
Now, you don't even have to do
Because they're all positive.
exactly, right? The next one we would do is +2, right? And that's similar to -2 because it's going to be squared, 4th, squared, right? So aren't we going to get the same exact answer as we did when we plugged in -2? Except it's going to, yeah. So it's going to be positive over positive, which equals positive.
Okay, but he's gonna get better mental math from that.
Okay?
Yeah,
We're done. We just have to sum it all up. Okay? We just have to just explain what we found.
Yeah, this one, the 16 that was
Okay?
I can't hear you, what?
I just think that like the Tweedle Beetles, not this one.
Because I can't talk. I can read though.
You got bars. You can't.
All right. Concave up from -infinity to -1 or 1 to positive infinity.
No.
Concave down. -1 to +1. Inflection points. Yeah, we had 2 because it changed, right? the concavity changed at -1 and then it changed back at +1. So we have inflection points at x equals -1 and x equals 1. Oh wait, I should have put, since this is your notes, I should have put justification. So why do we know that it's an inflection point? Because the second derivative, it's where the second derivative equals 0. Didn't ask for justification, but eventually they will. And it's best to have them in your notes so that you can always refer to them back.
There you go.
Why was it concave up? Because the second derivative was positive, greater than 0. Why was it concave down? Because the second derivative was negative, less than 0.
In the shade, guys.
Okay. All right. All right, so the next thing is a table. I put a table because they're going to ask questions where they say, where is it increasing and concave up? Where is it decreasing and concave up? They're going to mix first derivative with second derivative. So I put the table there to kind of give you a visual of what it looks like. So if the first derivative is positive and the second derivative is positive, it's increasing and concave up. That's kind of what it looks like. Picture in your head. If the first derivative is negative and the second derivative is positive, it's still concave up, but it's decreasing, right? So it's kind of a, yeah. Okay? All right. So, all right, so let's do number 3. So number 3 is just a mix of what we did earlier last week, or at the end of last week, I think, and what we're doing today. Okay? So they want us to, where is it both? So not where is it decreasing and where is it concave up. They want to know both. So it has to be decreasing and concave up. So they're looking for, where is it? Right here. They're looking for that guy there. Okay? So that's where the first derivative is negative and the second derivative is positive. So the first thing we got to do, find the first derivative.
Seems big and evil.
6x squared minus 60x plus 54.
I'm plugging 1 into that, guys.
Where this guy equals 0, 6x squared minus 60. Yep, we can divide by 60 when we set it equal to 0. You can, or not by 60, by 6. You can divide by 6 to make it smaller. It's a trinomial.
Guys, don't plug in 1. Oh no, we plugged in 1.
So a little bit of mental math. What multiplies to be 9 but adds to be negative 10? There you go, -9, -1. So we're going to get +9 and +1. These are critical values. Right? This is first derivative. So it's going to look like we did what we just did, but it's not going to tell us anything about concavity. It's going to tell us about increasing or decreasing. Okay? You can use any of those versions, any of these versions, this guy, this guy, this guy, or that guy, when you're checking for plugging in numbers. They're all the same. They're all equivalent. One's just factored, one's not. So 0, first derivative for 0. I'm going to use the factored one because that's the easiest one to use. Oops, not x. 0 minus 1. So we get 6 times -9 times -1 makes positive 54. 6, 2 minus 9, 2 minus 1, 6 times negative 7 times 1, negative 42.
Oh. Darn. 10 now. Oh.
10.
Wait a minute. I think I've
6,
seen this answer before.
10 minus 9, 10 minus 1. 6 times 1 times 9, 54. Positive. So increasing, decreasing, increasing. Okay. I'm not going to write up anything yet because the question was, where is it both decreasing and concave up? Okay, so let's look at our answer so far. So far, our answer can only be between 1 and 9
Okay.
because that's where it's decreasing. Okay, so we're going to focus.
This seems sucky. Well, at least you know what you're doing.
So we narrowed it down quite a bit. So most of the time you see these, it's going to be multiple choice questions. So the way I do it is look through your A, B, C, D. If any of those are outside of 1, 9, cross them out because they can't work. Okay? Cross out or whittle it down your choices. Okay, so now we're going to do second derivative to see where it's concave down. Or concave up, sorry. Okay. So second derivative is 12x minus 60. You can divide them both by 12, or you can just add 12, or add 60, divide by 12, because it's linear. Divide by 12, you get x equals 5.
I think I did this right. I think.
That's an inflection point, okay? That's an inflection point. Okay, so let's do, only got 5, so we only have 5. So second derivative, we want to choose a number less than 5, so 0.
That's a big one.
Wait, no, I don't want to choose 0. Why don't I want to choose 0? Yeah, because I know my answer's got to be between 1 and 9, right? So I want to choose a number that's less than 5, but bigger than 1. 2. 3, 4, any of those will work.
I did. No, that's bigger than.
So 12 times 2 minus 60. 24 minus 60, I don't know, 38? 36, negative 36. Again, I don't care if it's positive. I don't care what the number is. I just want to know the sign. And then I want to choose a number bigger than 5, but less than 6. 6. 12 times 6 is 72. Minus 60 is positive 12.
Very cool.
Okay.
From 5 to 9.
So now let's go to our, so what we're focused on is concave up, right? Concave up is here to here. So this can sometimes be hard because you have to kind of put both on top of each other to see where it's both true. Where is it both decreasing and concave up?
5 to 9.
5 to 9, right? So this would be right on top of there, so it'd be 5 to 9. So from 5 to 9 is where it's decreasing and concave up. Watch, I'll show you. You kind of what you got to do in your head. You got to kind of do this in your head. Okay? And figure out where. Well, where do the yellows line up on top of each other? 5 to 9. 5 to 9. Okay. Okay. So we would say
This one, holding the two.
Oh shoot, you're right.
f of x is both decreasing and concave up
Smooth.
from 5 to 9 because f prime of x, decreasing, right? So is negative, and f double prime of x, concave up, is positive. So it's nothing you haven't done, it's just combining the two.
This is a fifth math class. This is more biting than statistics.
Okay.
It's less statistics than any other thing.
What are you talking about?
All right.
It's a fake math class. It's a fake math class.
Okay, so I want you to do the next one. I want you to try the next one on your own. Last thing we're going to do today is example 4. So do example 4 on your own.